Let's carry this addition in standard form. Solution. If this is the first time you are watching video on standard form in this channel, please watch the previous videos. It will be a guide and give us a ground or foundation on standard form, the positive powers, the negative powers, and the rest. So I'll build on what I have taught in the succeeding videos. So please watch those videos. Sorry, I'll build on what I've taught in the previous videos. So watch them if you are going to find some things that will be done in this video difficult to understand. That's what you should do. Okay, let's proceed. Number 1. If P is equal to 5.7 times 10 raised to 6 and Q 1.8 times 10 raised to 6, find P plus Q. So P plus Q is equals to 5.7 times 10 raised to the power 6 plus 1.8 times 10 raised to the power 6. Okay, so what we do is that we can only add this part, and okay, since the powers are the same, we're going to factor out the powers. Remember from your maths of common factors, 10 to the power 6 is common to both sides, so we factor out. If you have EX plus BX, this multiplication, and a sum. So X is common, so we can have A plus B. Also, to bear that in mind and apply this in principle here. This is 1.8 times 10 to the power 6, 5.7 times 10 to the power 6. So in both cases, 10 to the power 6 is common, so we can factor the 10 to the power 6 out. So we factor 10 to the power 6 out. So this will give us 10 to the power 6 over 5.7 plus 1.8. Now we can add or do our addition arithmetic. 5.7 and 1.8 plus 7 plus 8 will give us 15 times 5 plus 1, 6 plus 1, 7 plus 7.5. So this is equals to 10 raised to the power 6. Remember this brackets multiplication, we can say 7.5. So this equals to 7.5 times 10 raised to the power 6. That's number 1. That's number 1. Number 2. Add 134.62 to 0.034, expressing your answer in standard form. So we're going to have 134.62 to 0.024 plus. Some students have difficulty when it comes to arranging decimal numbers for addition. Sometimes you even make the mistake of arranging it like this: 124.6 to 0.034, and then the add is wrong. The answer can never be correct if you arrange it like this. The principle behind it is that always use notation, your place value notation. For whole numbers are numbers without decimal points. So we have here, this is 2, 2, 4. This is a whole number greater than the decimal point. So once it has a decimal point, there's a 0.2. We call it a decimal number. So this part after the decimal point is called a decimal fraction or decimal number or first decimal number. And this point is called decimal point. And these numbers are called whole numbers. Okay, so our place value system 2, 2, 4. Unit times 100. If you have another number, this is 7, this becomes 1000. If you have another number, you know how the notation goes. Now after your decimal point, the first figure, let's say we have 2, 4, 5. After the decimal point, the first figure It's not units, it's tenths. The next one is hundreds, and then we have thousands. If we have another, we say 10,000, 10,000, 100,000, millions, 10 millions, 100 millions, billions, like that. So that's a notation for decimal numbers. So what you do is you arrange them in order. If you have 2, 4, 2 plus 2, 4, 6. How do you add? Okay, yeah, I have already arranged it. When you arrange them like this, you see that units things onto it. You can see that units under units, tens under tens, hundreds under hundred. Same thing applies here. So for a number like this, 134.62, this is your unit, this is your tens, this is your hundred. So 0.024. This is our tenth, this is our hundred, and this is our tens, hundred, thousand. So our arrangement will not follow that. 0, which is our unit, should be under unit. This is 0. This is our tens. This is tens here, and this is hundred. Then this is thousand. That's the appropriate arrangement. So this is the appropriate way to arrange it. Make sure that units stays under units, tenth under tenth, hundred under hundred. So for this particular one, you can see the way I put the notation. This is your tenth. Tenth in the first figure is this. Hundred is this. So your tenth should be under tenth, and your hundred should be under hundred. And most importantly, the decimal point should be at the same point. I think that will guide you. Once you fix your decimal point at the same point, opposite each other, then the next ones should be in the right order. Then you add. So that's exactly what we have here. So here, yes, nothing. So it's 4 plus nothing equals 0. 0 plus 4 will give us 4. And then 2 plus 3 is 5. 6 plus 0 is 6. The decimal point 4 plus 0 is 4. 3 and then 1. So this is 134.65 as the addition. But it's not a standard form. So what do you do? Convert 134.654 to standard form, or write it in standard form. So 134.654 is equal to the decimal point is already here. So if you move it backwards, you're going to make that movement 2 times. That's 1, 2. That will give us 1.3464 times 10 raised to the power 2. This particular case, just the decimal point 134.654. The decimal point is not here. So if it were here and we changed or write this number in standard form, movement should have been from here 1, 2, 3, 4, 5. That's 10 raised to the power 5. But in this case, the decimal point is here, and it's from here we are moving backward. So this will be 1, 2, which is equal to 1.34654 times 10 raised to the power 2. That's going to be the answer. So if this number is too large for you, you can simply write 1.35, which means you rounded up. This is 6, and is 0, is 0, add 1 to 4. So this is 10 raised to the power 2. You can say write it like that, but always take note where the decimal point is and do your conversion from there. So this is the answer to number 2. So we find the sum of 7.39. Find the sum of 7.39. 7.39 times 10 is equal to, and plus 9.6 times 10 raised to the power 4. Now in this particular case, the powers are not the same. So what we're going to do is that we're going to ensure that the powers are the same. So in this particular case, we're going to okay, So this is equals 7.39 times 10 raised to the power 3 plus 9.6 times 10 raised to the power 1 times 10 raised to the power 3. Why are we doing this? So that 3 and 3 will be the same, and then we can factor the power out since they are the same. Remember that from the indices, 10 raised to the power 4 is also equal to 10 raised to 1 plus 0, and 10 raised to 1 plus its multiplication is 10 raised to 2. So that's what I did here. So with this 10 raised to the power 1, it means I should move this decimal point forward. Since I only need 10 raised to the power 3 because it's 10 raised to the power 3, and I need to factor the power out since they are the same, then I'm going to simplify this part first. So 9.6 times 10 raised to 1 is equal to, move this decimal point 1 place forward, I'll give you 96. So 7.39 times 10 raised to the power 2 plus 96 times 10 raised to the power 2. Now we can factor the power out. So this is just 7.39 plus 96 times 10 raised to the power 2. Okay, so this is equals to 7.39. So same issue. Now in this case, 7 is units and we don't have tenths. We have tenths, but this 96 does not have decimal part, just 96. So this is units and this tenths. So the unit should be under unit 6. So when you write the tenths here, so this will put 96.00. You can as well put 0 here if you want, or you can ignore the zeros and add as you already. So this is 9, 0, 7 plus 6 is 13. Then you bring down 13. 1, so that's 10, 102.39. So there's 102.39, 10 raised to the power 3. So this is 102.39 times 10 raised to the power 3. Now this particular figure is not a standard form. To convert this to standard form, which means we need to move a standard form. The decimal point must be between the first significant figure and the next significant figure, or it should be at the first known 0 digit, just after the first known 0 digit. So move it until you get to the first known 0 digit, which is 1, and drop it there. So when we make this movement, and it must be backward because it's here, and for it to be here, we must make this movement backwards. So this will be 1, 2, as equals to 1.0339 times 10 raised to the power 2. Remember, we also have 10 raised to the power 2 here, 10 raised to the power 2. Okay, so since the powers are the same, the base is the same as multiplication, from the law of indices, 10 raised to the power 3 times 10 raised to the power 2 and 2 is equals to 10, 2 plus 2. So this was 1.0339 times 10 raised to the power 5. 10 raised to the power 5. That's the final answer. Number 4, 6.28 times 10 raised to the power 3 plus 9.5 times 10 raised to the power 4. First thing we must do is to make sure that the powers are the same. So here's 3, so we need to reduce this to power 3. 6.28 times 10 raised to the power 3 plus 9.5. So we split this power times 10 raised to 1 times 10 raised to the power 3. This is equals to 6.28 times 10 raised to the power 3. Then we will simplify this part. This will give us plus 95 times 10 raised to the power 3. So now we can factor 10 raised to the power 3 out because it's common to both sides. So 10 raised to the power 3 is equal to 6.28 plus 95. 10 raised to the power 3, 6.28, 5, 9, 8, 2, 6 plus 5, 11, 101.28 is equals to 101.28 times 10 raised to the power 3. Convert this to standard form. 120.0128 times 10 raised to 2 times 10 raised to the power 3. This is 1.0128 times 10 raised to 2 plus 2. And this is 1.0128 times 10 raised to the power 5. In 1976 and 1977, the crude oil production in Nigeria was 7.580 times 10 raised to the power 9 and 7.677 times 10 raised to the power 9 barrels. How many barrels were produced altogether? How many barrels were produced altogether in those years? Give your answer in standard form. So altogether, the word altogether means addition. So that's just a 7.677 times 10 raised to the power 9 plus 7.580 times 10 raised to the power 9. So since the powers are the same, we simply factor out the power 7.677 plus 7.580. Then we add them together. So let's say 7.677 plus 7.580. 7 plus 8, 15. 6 plus 5, 11 plus 1, 12. 7 plus 7, 14 plus 1, 15. 15.257 times 10 raised to 9. 15.257. 15.257 times 10 raised to is 9. We convert this to standard form. Remove the decimal point from here to 1.5257 times 10 raised to 1 times 10 raised to is 9. So we add this together. 1.5257 times 10 raised to the power 10. That's the sum. And this is the amount of barrels of crude oil sold altogether in those years. Number 6. So find the sum of 7.28 times 3. Find the sum of 7.28 and the sum of 7.28 times 10 raised to the power 3 and plus 9.5 times 10 raised to the power 4. Okay, so first thing is to make powers the same. So this is 7.28 times 10 raised to the power 2 plus 9.5 times, for 10 raised to 4 we have 10 raised to 1 times 10 raised to the power 2. So this will give us 10 raised to 1 times 9.5 will give us 7.28 times 10 raised to the power 2 plus 95 times 10 raised to the power 2. So factor 10 raised to the power 2 out. 7.28 plus 95. So come over here. 10 raised to the power 2. So 7.285982.7 plus 5. So 102. 102.58. So 102.58 times 10 raised to the power 2 plus 10 raised to the power 2. Convert to standard form. So 1.0258 times 10 raised to the power 2 times 10 raised to the power 2. That's 1.0258 times times 10 raised to power 5. Let's look at these examples also. The first example discover that either the powers are slightly different or they were okay. I think the observation was that they were all positive powers, but just that either one is higher or the other is lower. So, but in this case, and in that first those first set of examples where the powers were all positive, there was a way we could make sure that the powers are the same, and they were factored out the power that was the same, and then we simplified and we solved until we added and then got an answer, the sum in standard form. But if you look at these examples that we're going to treat now, the powers are different in the sense that one is positive, the other is negative. This is negative, positive, this is positive, negative. So you might be wondering, so how, in a case like this, what would I do? The simple thing you're going to do in this case that because the powers are different, this is positive, this is negative, there's no way you can make both powers to be the same and factor out. So the only approach to this problem is, or to these problems, is that you're going to convert each of them to ordinary form and then do your addition in ordinary form, and your final answer is what you're going to convert back to standard form. So let's see the solution. Solution number 1. So 7.5 times 10. Oh, okay. Supposed to be 1.4 times 10 raised to 3 plus 7.5 times 10 raised to minus 2. 1.4 times 10 raised to power 3. You're moving the decimal points forward. So 1.4, 1.4. Since the power is positive, you're going forward to 1, 2, 3, 0. So this is 1, 4, 0, 0. 1,400. That's 1,400 plus 7.5 times 10 raised to minus 2. If negative power, so you move your decimal points backward. 7.5, 1, 2, 0.0. So you put 0 here, like 0.075. 0.075 equals to, so you add 1,400 plus 0.075. Your point here, supply these zeros, and we proceed. 0 plus 5 is 5, 7, 0.0041. That's 1,400.075. That's equals to 1,400.075. So you convert this sum to standard form, and then you're going to move the decimal point backward until it gets to the first known 0 digit, which is 1, and just stop there. So that movement will be 1, 2, 3. So this equals to 1.4. So I write 1.4 times 10 raised to 1, 2, 3, 10 raised to 2 as a final answer, or you can see, or the answer is 1.4000075 times 10 raised to power 3. Now you're including all the figures, doesn't mean the power will change. No, the power is 10 raised to power 3 because the decimal point was moved only 3 times because it was here. 1, 2, 3. And these zeros are still significant because they are in between, they are among, the zeros are among significant figures. If they were after the last significant figures and the decimal point is here, that would render them not significant, so they could be done away with or ignored. But in this case, you could write them like this, or like I did here, since 0, I corrected it to the first decimal place, which is 4. And this one is not up to 5, so I rounded down to 1.4 times 10 raised to power 2, which was the first case, or you write down everything and still raised to power 2. So that's your answer number 2. That's 1.54 times 1.54 times 10 raised to minus 4 plus 9.8 times 10 raised to the power 2. Since the powers are not the same, we want to express them in ordinary form. So 1.54 is negative power minus 4. So we're moving backwards 4 times. 1, 2, 3, 4. Okay, 0, 0, 0. So that's 0.0005154 plus 9.8 times 10 raised to the power 2, 9.8. We're moving decimal point 2 to place it forward. 12.0. That's 980 plus 980. So when you add, you're going to have 980.0000154. So we convert the standard form, you're going to have 1, 2. You're going to have 9.8 times 10 raised to the power 2, or you can say 9.8 0 1 2 3 4 1 2 3 4 1 5 4 times 10 raised to the power 2. Either of them is correct, but I think this is preferable in most cases. Number 3, evaluate 6.63, evaluate 6.63 times 10 raised to minus 4 plus 10, 10 raised to the power 4 plus 3.4 times 10 raised to minus 4. So 6.63 times 4 means move forward 6.63, move forward 4 times. 1, 2, 3, 4, 0, 0, 0, 6, 6, 6, 3, 0, 0, 6, 6, 3, 0, 0, plus 3.4, 3.4 minus 1 means move backwards 4 times. 1, 2, 3, 4, 0, 0, 0. 0.0004, 0.0004. So the sum will give us, this is equals to, so the sum will give us 6600.004. Convert this to decimal, this will give us equals to 1, 2, 3, 4. 6.63 times 10 raised to 4, or we say 6.63 1, 2, 3, 4 2, 3, 4 3, 4 times 10 raised to power 4.